Hello, and welcome to Tea Time Physics. Today we're going to be looking at impulse and momentum and everything in between. To sum up for the day, the vocabulary we are going to be focusing on is impulse, momentum, inelastic collisions, elastic collisions, and the conservation of momentum. First, let's look at momentum, which can be described as mass in motion. Momentum is also a vector quantity, which means it has both magnitude and direction. Magnitude is just the quantitative data, which means it's the numbers in the data. For example, this can be 25 miles per hour, 13 kilometers per hour, or 12 inches long. Now let's look at an example of momentum. Let's say this Jeep is driving at a constant speed down the freeway. If the gas is let up, the car will still continue forward because of a force known as inertia. In order to stop the car, the brakes would need to be applied. This is an example of momentum because inertia proves that there is momentum. If there was no momentum, the car wouldn't even be moving in the first place. Next, let's look at impulse. Impulse can be described as the amount of time a force is applied to an object. Looking back at our earlier example with the Jeep driving down the freeway, we can look at the car's brakes to describe impulse. For example, the car will slow down more abruptly when the brakes are applied for longer, harder bursts of time. However, if you only apply the brakes in short little bursts at a time, the car is going to jolt forward and yes, eventually come to a stop, but it's going to take a lot longer. This is an example of impulse because the amount of time you apply a force to the brakes changes the momentum of the car. The car's momentum is going to slow down if you apply the brakes. Next, let's look at elastic and inelastic collisions. First, we're going to look at elastic collisions. Elastic collisions are just a collision between two objects in which they use Newton's third law of motion to repel each other. For every action, there's an equal opposite reaction. For example, if these two cars are driving at each other and they collide, they will bounce off of each other because the amount of force that the Jeep applies to the red car is only going to bounce right back at him. And same thing for the red car. If the red car collides with the Jeep, it's just going to bounce right back because it's using the same amount of force it was applying onto the Jeep. This example shows an elastic collision because the two cars bounce off of each other instead of sticking together. Now you might have guessed it that inelastic collisions are just the opposite of elastic collisions. If we look at the same example of the two cars going straight at each other and colliding, they won't bounce apart from each other. They're just going to stick together. The reason for this being that Newton's third law of motion is not present in this situation. The cars are not exerting the same amount of force on themselves that they exerted on the other cars. Instead, whichever car had the most amount of momentum is going to determine the direction in which the two cars travel after the collision. The Jeep is heavier than the red car, which means it has a higher amount of momentum if they're going at the same speed. Which means when they collide, the Jeep is just going to push both cars this direction. This example shows an inelastic collision because the two cars are going to stick together. And Newton's third law is not present in this situation. Every action does not have an equal opposite reaction. Now to sum up, let's show an inelastic and elastic collision once again. Here we go with an elastic collision, which means they will bounce off of each other. Alright, and here we go with an inelastic collision. See how they stuck together? Alright, the last very important piece of momentum that we're going to be looking at is the conservation of momentum. The conservation of momentum is actually much more simple than it may sound. It just means that no matter what collision occurs, elastic or inelastic, the system total of momentum is going to stay the same before and after the collision. You might be asking what a system total of momentum even is. The system total of momentum can be described again with these two cars. Let's say the red car has a momentum of 20 kilogram-meter per second, and the Jeep has a momentum of 30 kilogram-meter per second. When we look at the system total before the collision, it's 50 which means it's both the red car and the Jeep's momentum put together. After the collision, the conservation of momentum states that the system total of momentum is going to be the same before and after the collision. So the system total momentum is still 50 kilogram-meter per second. Does it make sense now? This example proves the conservation of momentum because the system total is the same before and after the collision. Alright, lastly, we're going to be looking at the formulas and some example problems of momentum and impulse. First, let's look at the formula of momentum. Momentum equals mass times velocity. Written in the correct units, this is kilogram-meter per second equals kilogram times meter per second. We are going to be looking at an example where a car of 1,000 kilograms is going 20 meters per second. What is the momentum of that car? Well, when we look at our first equation, kilogram-meter per second equals kilogram times meter per second, we just plug in the variables. So we get kilogram-meter per second equals 1,000 kilograms times 20 meters per second. Our final answer is going to be that the car has a momentum of 20,000 kilogram-meter per second. Next, let's look at the formula for impulse. Impulse is just force multiplied by the change in time. When we write this in the correct units, we can use I to represent impulse and N to represent force, as in newtons. Written out, this would be I equals N times the change in T. Change can be represented by a triangle. Looking at an example, if we have a constant force of 50 newtons being applied to a 20 kilogram block for 10 seconds, we can find the impulse. Remember, the impulse is equal to the change in momentum. When we write this out, we get impulse equals 50 newtons times 10 seconds. In the end, we will get the impulse of this situation equals 500 newtons times seconds. Alright, that wraps it up for our lesson on momentum and impulse. Let me know if you have any questions, and until next time, bye!